Good morning. My name is Luke, and I'm here to talk to you about the 5 things that I believe every developer should know about modern identity platforms. Have you ever been in a project where the project manager or PO walks in and says, I'm going to ask you to go ahead and add some new social login features to the platform. And while you're on it, maybe you can add some government identity as well, because we are thinking of selling these health insurances later on, and well, we need to have a verified identity for that, of course. And if I can log in as my corporate user to do administrative work on the site, that will also be immensely helpful. And while you're on it, make sure that everyone has single sign-on support, please. Well, that's kind of a challenge, right? And I hope that during this talk you will pick everything up that you need to know and walk out of this room feeling confident you can do it yourself. But first, to introduce myself really quickly. Hi, my name is Luke. I am a cloud architect. I work at Xibia, which is a company all the way in the Netherlands. And well, over the past years I've been having some projects like this, and I made this checklist that everyone probably will need to go through in order to get their stuff into production. Well, first, of course, if you want to do something with an application, you probably also want to store some user information. So you need an IDP for that. And then you need to, of course, connect your applications so they can use that IDP and start logging in. And if you deploy one of those things, you probably want to have some control over it. So you want to make sure that everything goes well from A to Z. And finally, you need to keep an eye on your system. And during this talk, I will check off every item in this list, walking you through it. But first, what is an IDP? Well, in my mind, an IDP consists of these 5 main elements. So first and foremost, it needs to have a place for user accounts and passwords. Then you need to specify which applications can use it and what they can do with each other. Then, of course, your application needs to do some kind of login, usually. You probably want to have some automation options around it, so you can do CI/CD even on your IDP. And of course, you need to have a logging and monitoring system, so you can take a good look at your IDP and to see if everything is still going well. Well, why the hell do we need IDPs anyway? In the old days, it was not uncommon for every app to have its own user account administration. And of course, that also comes with all the roles inside the app and probably some profile information. And then if you have 5 apps, you will have 5 user accounts with 5 different roles and probably a lot of sticky notes on your monitor, or at least hopefully a really good password manager keeping track of all these account details for you. Well, at the same time, we saw that it's not uncommon for companies right now to store petabytes of data. And well, all this data is probably very interesting for attackers. And imagine if you have a different identity technology for every application in your corporate domain, then it's going to be really hard to make sure that everything is up to speed, securely patched and monitored and upgraded on time. So we want to have sort of a standardized way to protect all these systems. At the same time, we saw that applications became distributed. So instead of having these monolithic silos that do a lot of stuff on their own, it's not uncommon for applications to talk to each other nowadays. So you can have a front end, multiple APIs, administrative services, SaaS services included to the mix, everything. And again, you want to have a standardized way to make sure that identity flows through all these systems in the same way. So you can have, well, a good, confident feeling about that everything is securely protected. Well, why do I feel you need to know about this? Well, it's very popular technology. There are literally billions of applications on this planet that use an IDP. So it's very likely that you will encounter one of these things in your current or your future project. And of course, if you do this right, then you don't need to worry about security too much, and you can, as a developer, you can focus more on adding business value and trust your IDP to keep your data safe. Well, of course, then you can still choose to run your IDP, well, in multiple places. So you can have an IDP for every application. Well, I say it's best not to do that. So if you have one centralized IDP somewhere in your organization, this will enable account reuse. So instead of having a different user account for every application, now all of a sudden you can have one account, excuse me, and use that to log in on multiple systems. And of course, this also brings SSO features. So logging in at the beginning of the day and then using that session for the rest of the day, no matter which app you use. Of course, at that point, it becomes easier to add multiple applications to the same IDP. And adding more is really just a matter of repeating the same tricks. And having a single IDP is easier to defend. Well, of course, you need to make sure that this IDP is really, really rock solid and reliable. And this is why you need to think about whether you want to run it yourself or maybe use a SaaS offering for this. An IDP, well, if you consider it as a single point of failure in your application, that means if your IDP is broken, none of the users can use any of the applications. So you really want to make sure that your IDP is running very securely and highly available. So I say, if you are a developer, you are focusing on building business software, it's probably best to trust another vendor building your IDP. So if you have the choice, don't build your own, but instead pay a trusted vendor to run this IDP for you. Sorry. I'm recovering from a cold, so you'll be getting a few of these. All right, so I always like to build nice demos for my talks, and today is not different. So I've built this nice Xperit insurance company, and it has two front ends and an API. So the front ends are both single-page web applications. There's a reason for that. And then the back end is just a common REST API, and I built everything in .NET. So let me quickly show you that. So this is the sales app, and of course green is the color of money, and that's where my CSS skills end. So this is about as good as it gets. But this is the sales app in which you can log in as a customer and then say, well, I want to get some quotes for my insurances, and yeah, for example, give me a quote for my house insurance, and then if this price looks good to me, I can go ahead and buy this. And then there is the claims app in which a user can log in whenever they have some damages, and then they can use their insurance to claim some money. Well, same thing, I can log in. The difference here, of course, is that I'm using SSO here, so I didn't have to re-authenticate because I'm using a different app, but the same IDP. My account is already signed in, and I can go ahead and claim some money for my house insurance. Well, we will be coming back to this application quite a few times, so at least now you are familiar with it. Right, so a modern IDP, it has a place to store your user accounts and passwords. Aside from having user accounts in there, it's not uncommon for an IDP to also support groups of users and system accounts as well. You can use these system accounts to identify an application and make sure it can have access rights to other applications as well. Of course, you need one of those user databases will also need to store passwords. And generally, these are hashed, which is an irreversible process to, well, make something else out of it, so you don't have the plain text password in your database and just compare hashes. Sometimes an IDP also can store these things called roles and permissions, meaning that you can define which user can access which application or which system can access another system. Well, it's not uncommon for one of these databases to have profile information as well, so you can store stuff like birth dates, addresses maybe. Generally, you don't see too much profile data in an IDP anymore. What's also important is that a user account can have multiple identities attached to it. And this is, well, way down the talk later on, we'll talk about this, but you can have different identities linked to a single user account. Keep that in mind. Well, if you look at a user, then generally there are two different flavors of users. So the first is probably your end customer. Your end customer logs into your, in this case, to my sales front end or my damage claims front end. And they want to use the platform. And then when they do log in, they expect the style of the application to appear, and then the look and feel of the login process should closely match the look and feel of the application itself. And then, a different user is an enterprise user. So imagine you are running one of these Experience insurance sites, and then you probably want to log in as an administrative user using your enterprise account. Well, there are different flavors of IDPs you can choose from. So if you look at consumer IDPs, then Azure AD B2C, for example, is a really nice choice. It's a platform offered by Microsoft. It is currently being replaced by Entra ID External Identity, which is the vNext of Azure AD B2C. It's not GA yet, however. And another popular consumer IDP is Auth0. It's currently owned by Okta, which is a really renowned IDP vendor. So if you ever are in the market of choosing a customer IDP, then please make sure to have a look at these ones. And then on the other hand, if you are looking at corporate identity platforms, then most popular ones in this area are Entra ID, which is, well, Azure AD vNext, or renamed actually. And like I already mentioned, Okta and Ping are also front runners in this area. Right. If you don't want to use a SaaS offering for IDP, then it makes sense to look at these ones. So Duenda Identity Server, that's one of my personal favorites. I've worked with it quite a few times. It is, well, a really good way to go. Keep in mind that if you do use one of these open source offerings, so Duenda comes with full support, WSO and Keycloak, you will need to be running them on your own. These are generally not as rich in enterprise features as, for example, Azure AD would be, like conditional access, access reviews, all that sort of niceness, privileged identity management. These are all features you won't generally find in these self-hosted IDPs. So one of my personal favorites is Azure AD B2C. So this, again, it's about to be replaced by Entra ID External Identity, but it's not fully done yet. So that product, well, I'll move to it when it's GA. But for today, I wanted to show you a couple of features which are currently easiest to build in Azure AD B2C. And it still has about 5 years of support left. So in my mind, still a really valuable platform to choose. So it has 4 nines of availability. That means that the general downtime of this service is incredibly low, in a matter of minutes per week. So generally a really good choice. And it supports all these different authentication flows as well. So there are different protocols that you can use in this market, OIDC, OAuth, SAML. These are all fully supported. It's also highly customizable, meaning that you can apply the look and feel of your application to the login procedures you can add to B2C. So you can customize the flows to make sure that they look a lot like your application, so the end user doesn't feel like he's moving to a different website for login purposes. And finally, it allows you to do a lot of operations in an automated way. So it comes with an API that you can talk to and make sure your IDP is configured the way you want it to be using infrastructure as code, PowerShell, for example, or Terraform. And it also comes with monitoring support, so you can take the telemetry that flows out of the platform and store it somewhere in Application Insights, for example, an Azure service, and then you can keep an eye on it and maybe raise alerts for stuff that may be going wrong. Right, so let's have a quick look at Azure AD B2C. So this is it. Well, the easiest part here, of course, is the user account database. Well, this is one account that has done a self-service sign-up. I can do stuff like password reset for this account, add it to groups, all that sort of niceness. And then, let me quickly check here. Yep. They keep changing this, so it's sometimes it's really interesting to find stuff. Right, so for example, if you want to do monitoring of sign-ins for that user, you can go to, well, there's not a lot happening here yet, but interesting stuff like users typing the wrong password, all that sort of telemetry would end up here. And then, of course, I wanted to show you the customization bits. So you can use this, geez, I can't really, oh, forget it. The point I was trying to make was that if you configure the system properly, you can have these things called user flows, and then you can make sure that the look and feel of those flows, where the user provides their name and their password, and make sure it looks a lot like your application. Well, if that's not enough, there's also support for these things called custom policies, in which you can have, well, it's sort of a programming language in which you can make your own screens and then make sure the whole login procedure is custom tailored. Well, of course, your application needs to know about Azure AD B2C or your IDP in general, needs to know where it lives. And this is how you would do that in code. You add the proper NuGet packages. So, for example, adding this one, authentication WebAssembly MSOL, will make sure that you get these extension methods at MSOL authentication, and then provide a little bit of configuration, which you can put in a config file. And this line here, it says, okay, so whenever users are logging in, redirect them to the IDP here. And then this is like a trust connection between the application and the IDP. So here's the IDP, log in over there, and then get back to me. Well, the same deal, of course, happens on the API side, something very similar. You point it to a little bit of configuration, and then you can make sure that the API can validate tokens over there. But again, we will come back to that later. All right, so we can cross off the first item from the list. So an IDP can store usernames and passwords. But then, well, if you have an application, you probably want to well, make sure that the front end, for example, can use the API. And this is what I mean with the application integration. So the way you would do that is by adding these things called clients inside the IDP. So every application that you create will have a counterpart that lives inside the IDP itself. So, for example, I have 2 front ends and an API, so I will have 3 clients in my IDP. And then by configuring them in the right way, I can say, hey, this is front end. This one allows users to log in. And then I have my API here, and it is okay if my front end accesses my API. Well, let's apply that to our demo system. Then you can see that there is a sales front end there. And that means that there is also a client in the IDP that's registered that references the front end. And then the second client, of course, is the API, which implies that one. And then there will be a third one for the damage claims, and so on. Well, it's important to know that there are 2 types of clients. So the first one is the public client. And this is the client that represents an app that runs on hardware that you don't control. For example, if you have something that runs on a mobile phone or maybe something in a browser, my web app, for example, it runs in a browser. So I have no control over the end user's browser, of course. So this means I cannot store any secrets in there. And that makes it harder for that client to authenticate itself. And then there's this thing called a confidential client. And this is one that runs on hardware you do control. For example, some server in the cloud or a server on-prem. Or, well, any web server that runs pages and calculates or builds them locally and then sends them over as HTML. Well, in our situation here, that means that we will have one public client, which is the front end. That's that one, and it's public because it runs as a single-page app in my browser. And then we will have a confidential client, that is the insurance API that runs on a server somewhere. Right, okay, and let's have a look at Azure AD B2C again. Then we will go to app registrations. And for example, let's start with the insurance API first. So this is the first client to register, and I already know this is about an API. So what you can do is you can say, okay, this API, it will expose 2 roles. So an end user can either have read access or read and write access. It doesn't really fit, but if I paste it here, then you can see something like API.read. So the first one is read-only access, and well, you probably trust me that the second one has read and write access. So now I have an API that defines 2 access roles. So if my user has read access, I can make sure that the API can check that security and make sure that it will only return resources that have this permission attached. And then, of course, we will have something like a front end. And then, well, a front end, for example, has interactive login. So you need to configure that. So you do it in this way. So you make sure it has a reply URL. So after the user has logged in, you will need to get back to your application. And that's what's happening here. So this login callback thing here, that is the end user being redirected back to the application after authentication. And then, of course, we will need to have permissions on our API. And that's what you see happening here. So in this case, I configured my front end to have both read and write access for my API. And the fact that it's delegated means that it is not the front end itself that can access the API. No, it is the users of the front end are allowed to access my API. So you can have either direct access or delegated access. Direct access means app accessing other app. Delegated is users of an app are allowed to access another app. All right. Well, if you go back to the code, then you can build stuff like this. And these are definitions of authorization policies. So, for example, I can say, well, whenever a user accesses my API controllers, I need to make sure that there's somewhere that there's a security claim that offers read and write access. But if I want to do elevated privileges, for example, selling these health insurances I was talking about, then I need additional verification. And then it's not just enough to be signed in, I need to have a verified identity. Well, these are just the policies, of course, and then you apply these policies on your controller like this. So you say authorize attributes and then point to one of those policy names. And then for a special operation, you can say, well, it's not enough to have the default authorization, but this one needs additional authorization. So this is a very nice declarative way of making sure that APIs are authorized in the proper manner. And right now, I do realize it doesn't fully make sense yet, because where do these things come from? But don't worry, I'll talk about that in a bit. All right, so what we know now is we have a digital counterpart in the IDP, which is a client for every application that we have. But, well, how does one of those applications sign in? Or how do users for the front end sign in? And this is where the sign-up authentication endpoints come to play. Authentication endpoints pretty much means that either a user or a system wants to access a resource and they want to have permission to do that. Generally, this will use standardized protocols like OpenID Connect or OAuth 2. Well, these are just standards that define the interaction process needed in order to authenticate successfully. And the way this works is by using these things called grant flows. And while there are quite a few, I want to highlight just two of the most popular ones today. So which one of those flows should you use in which scenario? Well, the two most important ones are the client credentials flow and the authorization code flow. The first one is when a machine wants to access another machine, client credentials. And the second one is when a human being wants to access a system. So let's quickly dive into them in a little bit more detail. So again, client credentials, machine to machine. For example, my insurance API on itself wants to access a different API, or maybe an API on the IDP itself, doesn't matter. So this will require the client to have something to identify itself. So obviously this requires a confidential client. You need a little bit of a secret so the client can identify itself. And there's no human interaction here. So the client will have to have its that secret stored somewhere, maybe in a key vault or a certificate, whatever. And then it can use that to go to the IDP and get authorized and then get an access token back and do its magic. So the way this works, the application itself provides credentials directly to the IDP, and the IDP will validate those credentials, of course, and if they check out, they will return something called a token back to the API, so that the API can use that token to access that resource server somewhere. Well, the authorization code flow is a little bit more complicated, but I try to simplify it as much as possible. And the situation here is that a human wants to access a web resource, for example, and this will involve some kind of interaction. So a user typing in their name, or maybe provide a passkey authorization, whatever. But there's always a human being involved in this flow. The way this works is that the application will redirect the end user's browser to the IDP. The screens will be generated by the IDP itself, so the end users can log in there, provide their password directly to the IDP, not to your app itself. If it all works out, the IDP will return a token back to the application, and then the front end can use that token to call the API. And the final step would be, of course, for the API to validate the token it received from the front end, again by checking it with the identity provider. Well, you heard me talk about tokens quite a bit already. It's hard to avoid, but well, let's dive into the various types of tokens that you can encounter in the wild. So first and foremost, there's this thing called an access token. And that's the most important one, because that is sent to the resource server to be checked there in order to gain authorization to access a resource there. So generally, it will have a relatively short lifetime of about an hour. And it is sent from an application to another application, so it can access a resource over there. Then there's this thing called a refresh token. And because access tokens are relatively short-lived, you probably want to get a fresh one every once in a while. And you don't necessarily want the end users to do re-authentication all the time. So this is why refresh tokens exist. So this has a longer validity. It is not sent from an application to another application. It is sent from an application to the IDP to get a new set of tokens. And generally, you can't see what's in a refresh token, which is different from access tokens and identity tokens. So an identity token, that says something about a human being. So it doesn't happen for client credentials flow, it happens for the authorization code flow. So it identifies a human being, it will have information like an email address, some kind of a GUID, that is the unique identifier of that user. It could have profile data, pretty much anything you want. And this one generally doesn't flow from system to system either, so it will probably remain in the front end itself, where it can be inspected and, for example, being used to display the friendly name, so like the real name of the end user instead of their email address. All right, let's see that in action. And again, this is a little bit of a technical demo, but some people like it. Okay, I will log out, make sure everything is clean. All right. Okay, so I've filtered the experience here on just HTML pages and documents, which is pretty much the browser getting a full page, or the browser in script doing calls to the backend, and that's exactly what I want here. So when clicking on the login button, what happened was that my application was being forwarded to the IDP itself. So it went from localhost to b2clogin.com. It's probably really small, but well, maybe believe me. And then it was displayed this sign-in page. This page, it looks a little bit like my app itself in look and feel style, but it is rendered by my IDP. And then when I do sign in, go back to the network tab. Okay, not sure what happened there. Sorry, I need to redo it. Yeah. All right. Well, after typing in the right credentials, what happened was the IDP rendered a redirect page which says, hey browser, please redirect back to this login callback page I showed you before. But then it will apply a little bit of additional information to that request. So this is the redirect happening here. And then it will also pass in the authorization code, well, which then can be used by my application later using a fetch call to get a token. So application logged in, IDP sent the request back to my application. It got some secrets with it, and my application can use that secret to fetch these tokens. And as you can see, it will have an access token, ID token, and a refresh token. And these are, well, it already looks a little bit like base64. So the cool news here is that we can have a look at those tokens. For example, this one, that is the identity token. And we can just decode that base64 because it's not a secret, it's not protected at all. We can look at what's inside. And then you can see, for example, this has an email address and a username. And the same thing I can do for an access token, which is not about a human being, but a system wanted to have access to another system. So it will have stuff like the authorization level here. So that's all encapsulated, but visible inside one of those tokens. Well, you also saw me logging in to the green application and then being able to access the blue application immediately. And the magic happening here is, of course, cookies. And you have these cookies in two flavors. So you can have either a session cookie, which will be gone as soon as you close your browser tab, or you can have a persistent cookie, which will survive the closing of a browser tab. So it's just a matter of well, the admin defining what's acceptable. They can either show that checkbox or not show that checkbox based on corporate policy. And then the end user can say, well, I want my session to remain active at all times, or maybe log in once per day. So cookies are what's making this possible. Okay, so we can have we can cross off sign up, sign in flows, but linking to other identity platforms. Why do we need that? Well, you can imagine that if you have these customers, they are defined in B2C, but maybe some of your customers want to use social identity like Facebook to sign into your app. Or maybe they need to log in through a government IDP, which in the Netherlands we call DigiD, to sign in, because that's required to purchase health insurances. And then maybe there are these corporate accounts of administrators, and they want to log in using the corporate account because it has all these nice conditional access policies attached to it and MFA requirements. But a really poor way to do that would be to have like 5 or 10 IDPs in your app, because, well, you'll get this really big nightmare of code defining, well, where does this token come from? Where do I need to verify it? You generally don't want that. So if you do want to have customers to log in and also admin logins and also social and government logins, how would you do that? You probably want to solve this problem by doing something called identity federation. So federation is really just a matter of trust between multiple IDPs. So instead of having one IDP, you can have as many as you want, provided that there is this trust relationship between them. So the cool thing is, if you do this right, then you can have as many IDPs as you want, and you can have end users log in to the IDP that they want, but still in your app, keep it really simple with just Azure AD B2C or any other IDP that supports this. So this is the way it works. You add a trust relationship, for example, between Azure AD B2C, which is the consumer IDP, and then Azure AD or Entra ID, which is the corporate IDP. Well, there are different protocols, of course. So if you have IDPs, then generally you will also encounter multiple protocols. So this problem is also solved by having this solution here. So while you can have, for example, SAML authentication requirement for your corporate IDP, by doing this approach, you can still have just one protocol from your application to Azure AD B2C. So that remains the same. So you can hide away a lot of the complexity in the background as well. So, for example, if you want to add this admin login, what you need to do is make sure that there's a trust between Entra ID and Azure AD B2C. The end user will log in to the Azure AD after being redirected by B2C itself. Again, a little bit complicated, but really a really great way to go. Then, once the admin has logged in over there, the token is not sent directly back to the front end. No, it's sent back to B2C. And because there's a trust relationship there, it can read the token, just like we did in the demo before. It can take information from the token and then issue a new token based on the information there and send that to your application. So even though the end user has signed in over here, the app gets a token from over there. So one IDP to verify all tokens, no matter how many IDPs you add in the background. So if you want to add social or government identity to the mix, it is really a matter of doing the same thing. So you can add as many as you want. The complexity is all remained here. And then you can have many different protocols here and add as many IDPs as you see fit for your application. So the user will log in. B2C will need to redirect that user to the proper IDP, then get a token somewhere, and then the application will still get a B2C token. Right, so in this case, you will have one IDP, B2C. It will have one user account, and that one user account can log in 4 different ways now. So either local account inside B2C, or social account, Facebook, or government account, DigiD, or corporate identity, which is the admin user. If you apply this to our demo application, you will have this random user. It can have a local account with a fake email address, like Shark Lasers, for example, the one I'm using. It can have Facebook, meaning that, well, Facebook is responsible of determining whether that user actually exists or not, or whether their name is real. Or a government account in which or a corporate account in which the corporation, of course, has verified the identity of that user. Right, let's quickly see that in action. So I will first add a Facebook connection to my application. Well, for that, of course, I first need to enable the end users to log in through Facebook by selecting a different login flow, which I do here. So I'm going from this simple flow to this customized flow. Make sure to restart. Right. And what I can do now is link these accounts. So I will still have one account in B2C. I will sign in using that account. So B2C knows that it's me. And then I can say, I want to log in using my Facebook account and connect these identities to each other. Well, this is Facebook, as you can see. It's really not. And now I've also logged in at Facebook. B2C got the token of Facebook. It can inspect that information and see, oh, okay, so at Facebook you are known as this user, and in my system you are known as this user. I can connect these two identities to a single user account in B2C. So whenever I log in now, I can say, well, don't log in as Bruce W, but log in using my Facebook account. Well, I've been here before, so I get single sign-on. And now I've logged in, and as you can see above, it knows that my application is logged in with this user that is now known by two identities. So it's Bruce, and we logged in using Facebook, but it's still a single account. Right, well, let's add government identity to the mix. And the cool thing about government identity, of course, it's the most official way to identify yourself. So in this case, I add additional value to this login. So my user, if my user has an identity that is verified by the government, I am allowed to sell them health insurance. So log out first, and then link my local account by logging in first, and then link my government account. Again, not true. This is my government account that is now linked to the system. And no matter how I log in from this point, because this is all connected to the same user account, I can log in using my local credentials, Facebook credentials, or government credentials. Doesn't matter. I'll choose the local one. But now, because I sign in once using my government identity, I know that this identity is verified. And then I can put that information in my ID token. This is a custom claim I added during that customized linking procedure. So I said, well, this identity has at least once provided their government identity. So I know for sure that we know this person is really who they say they are. So my account is now verified. No matter how I sign in, Facebook, local, or government, this flag will just be in the system. And then I can start selling this person health insurances. Well, let's see if it actually works. And remember, there was a custom policy defining extra elevated privileges here. So I should be able to now buy this and not get bounced from the system, which is really nice. All right, so what you saw happening here was something called Identity Hub concept. So it means the upper flow is everything corporate. So your corporate IDP doing federation with partners, whatever, any kind of IDP that your corporation wants to federate with. And then your consumer-facing app will have all these consumer-facing IDPs, government, social, whatever you please. And then by linking these two together, you can have still this customer-facing service being logged in with anything that is from the top layer, or you can have corporate tools being accessible only through the top layer there. So by cleverly combining IDPs together, you can make it really easy for users to start accessing your systems while still being in complete control. Cool. Yeah, we are getting there. So we cross off the federation part. So the last two bits are kind of short, which is nice because I'm short on time. So automation. If you do choose a SaaS offering for an IDP, make sure it comes with these automation endpoints. So you can do configuration as code. So it's really, really nice if you have this test IDP that you can use to build your different flows, make sure that they work properly, and then promote them to production, well, preferably by using a pipeline. And then what you get is two tenants probably. So the first one is your test tenant, which you can use for dev test purposes. And because you're using configuration as code, or maybe even infrastructure as code, you deploy your production tenant using automation, and you probably can be very confident that everything works. So, infrastructure as code or configuration as code. right? And then finally, the monitoring bit. So it is really important that you keep an eye on what's happening in your IDP, of course. So please enable every kind of logging that you have, except for username, password, or token logging, of course, outside of the dev test environment. And then, well, capturing all this telemetry is not enough, of course. You will need to act upon it as well. So if you see that there's a login attempt failing for hundreds of times, then there's probably something wrong. So different things that can go wrong. So let me see this one. Yeah. So failed logins is something to monitor. Invalid tokens being sent to your API is something to monitor. And then, of course, crashed workflows. I did some customization here. Sometimes you do it wrong. Make sure you know about it, and then you get warned about these events, so you can act upon it. That's the final item from the list. This is the summary. Don't worry, I will not go through the entire summary again. But if you want to take a picture, that's fine. Right. I will also post the slides online, so if you're too late, it doesn't matter. So the final thing to ask for is to give us feedback. So if you have anything to improve on this session, please let me know. If you have any questions, the QR code is the same, by the way. Oh, it's already gone. Yeah, quickly. I put the QR code on this slide. So if you want to have access to the source code, then follow that bottom link. So everything is there, open source, ready to go. Yeah, finally, if you have any questions, this is a really nice moment.